Again, for the people who are attending for the first time, rather than go through the long list of credentials for each of the speakers, I tend to leave that for the speakers themselves. I'm more interested in telling you why I pick the speakers that I pick, so you know what motivates me to select people from different categories. This guy's really easy. Callum, come up here a bit closer. First speaker, we've got Callum Coates. This is his third presentation at Nexus Conference. He hasn't done one for about 10 years. In that time, though, thanks to people like Callum and a couple of articles in Nexus, there has been a growing awareness around the world of the work of Victor Schauberger, the magic and mystery of water. And I know that quite a few people in the room have probably bought Schauberger's books, read the articles in Nexus. And so Callum Coates is pretty much acknowledged as the world's foremost authority on the research of Victor Schauberger. He's had access to the archives and files and has made them available to the public in a very professional format too, I might add, Callum. So please give Callum a big warm welcome, Callum Coates.
Well, thank you very much. I'm looking forward to delivering hopefully a fairly consistent talk. I'm going to just say where this started for me, and actually this whole story with Victor Schauberger started when I was 16, but then there was a gap of about 20 years or so, and in 1977 I met his son Walter Schauberger, and from that moment on my life changed, in about a space of about 20 seconds. When I walked into Walter Schauberger's studio, and it was behung with spirals and all sorts of fantastic drawings and diagrams, which he developed mathematics so that he could explain his father's processes better. So I've been doing that. I've been involved with Schauberger since 1977. I've translated a lot of his works, Victor's works, from German into English, and the result of those is now out there if people are interested in getting hold of a copy. Now, excuse me, I'm going to have to put these on because I can't see without them. And this is Victor Schauberger. Victor Schauberger was born in 1885 in a family of a long line of foresters stretching back some 400 years, and who lived, by kind permission of whoever's up there, and they lived in Bohemia, in the forest, the deep, rich forests of Bohemia. And so he had forestry in his blood. And I'll just switch forward, if this thing works. The family motto was Fidus in silvi silentibus, which is have faith or belief or trust in the silent forest or the forest of silence. It depends which way you want to translate the Latin. And Victor's probably most important dictum was comprehend and copy nature. And that is really the only way forward in terms of all our technologies and so on. I'll just flick back to Victor again. Now, Victor grew up also, as I was saying, in this rather remote area. He had a very great gift for observation and perception, which surpassed even, most of his fellow human beings. But even as a child, he used to like to sit down next to a stream and watch the water, watch it move, watch the way it rippled and how it swayed backwards and forwards, all those things. And he gradually, this was a game to begin with as a child, and then eventually he realized that he could detach part of his consciousness and let it flow away with the water. And when it was returned to him, it brought him information from those places that the eyes cannot see, as he put it. And it was through this development, this constant association with nature and the forest, that he built up his various theories. He had two elder brothers, and they went to university, and Victor saw what happened to them as a result of this association with academia. And he realized that they had lost some touch with nature, some touch of the deeper understanding of the forest, because suddenly their view had become shoehorned, and they weren't as sensitive to things. So he refused to go, and his father was absolutely furious with him, but instead he went to a forestry school and started off as a low-level forester, working up gradually through the ranks. Then the First World War came, and he went to war, and then after the war he was wounded, and after that he became in the employ of Prince Adolf zu Schauberger, who was a German prince, but he had estates in Austria and Steyerling. And he took Victor into his employ, and Victor managed his forests. This was another part of Victor's learning process, and if I remember it, and then if someone says that there was a story about a spring which happened in those days, but I won't bring that up until I talk about spring. So if I haven't talked about it, someone say, hey, please. So anyway, this was after the First World War, and Schauberger had lost a lot of money, and he wanted to recoup some of his losses by selling off his very high-quality timber, which was sited in rather remote locations, difficult access, and so the problem was how to get the logs out of there. And he first went to the Forestry Institute in Vienna, and they sent some experts and commissioners down, and they drew up plans for sort of concrete log flumes, and that was supposed to work. And when Victor heard about this, he approached Schauberger and he said, look, I have an idea which I can apply and help you with, which is about the third the cost of what they're doing. It'll work much better. And so Schauberger said, well, if that's the case, I'll take you on. It's against the experts' advice, mind you, but if you're saving me a lot of money, well, then I'll do that. But you're going to pay for it. And if it works, I'll pay you. If it doesn't, you take it down again. And Victor thought, well, that's a good enough bargain. One of the preconditions for its successful function was that his log flume had to deliver 1,000 cubic meters of timber a day. Actually, it worked out on the first day, delivered 1,600. So Victor was paid. So now the whole process began on the day that everything was set up and ready. The holding basin, which was at the top of this log flume, had to be filled with water because it was from there that all the rest of the flume was fed with water. And so on the opening day, everybody arrived, and they stood looking into this basin, which is egg-shaped, as you see. Yeah, you can see. I can see here too. I've never done PowerPoint before, which is amazing. It was a very deep basin. It was quite, copious. It probably was about the size of, I don't know, maybe half this room or something. It was big and quite deep. And so the time came to fill it up, and Victor went out on the wall here and stood here and said, look, I'm just going to, oversee this, the filling. And the commission said, no, come back, because the water's going to go in there. You're going to die. Don't. And Victor just put his carbine up in the air and fired 2 shots. And that was a signal to his foresters further up the valley to remove all the barriers from the store of water which was going to fill this thing. And there was a huge rumbling sound and frothing and a noise, and around the corner came 4 meters of water full of logs and goodness knows what else. And Victor didn't move. And the water, when it came in, flowed around the edges and, of course, the underside. And then it created a wave in the opposite direction, which actually slowed down the rest of the water coming in. And so the basin held. And according to static calculation, it was 12 times stronger than it need be. Anyway, when it was full and it was sort of settling down again, Victor went back to where this group of commissioners and indeed Count Schauberger was, and he said, well, there it is. And the commissioners, they were relieved, so was Lippe. And one of them said to him, oh, Mr. Schauberger, that's very interesting. Where did you get the idea for the shape? And Schauberger said, oh, well, a chicken gave it to me. He didn't have much time for officialdom. Well, now, this is basically the design of a later flume that Victor built. This is at Neuberg. As you see, the cross-section of this flume is egg-shaped or half egg-shaped. And it's curving, and it's made of wood. And when it was being built, the workers said, well, where do you want to put this flume? And Victor said, well, you see how the water moves in this valley and how it flows around here and so on? Just copy it. That's how we're going to do it. We're not going to go in straight lines. We're just going to follow what nature has already dictated for water to move in this place. So, inasmuch, of course, that they had to maintain a particular gradient. Now, the way the flume worked is that in the settling tank, which is actually egg-shaped, I'm sorry, this diagram was drawn before I did the egg-shaped one. I didn't change this one. And gradually, after the water settles, it stratifies according to temperature, so that the lowest temperatures are in the bottom. And Victor used waters of different temperatures from different levels to feed into the flume at a tangent, so that the thing is with waters of different temperatures is they don't mix. And this is the secret of why his system worked, because he developed, or he initiated these vortices with a very colder water in the center, which were able to carry logs heavier than water, because the only place that a heavier log could float was in the center of the heaviest water. That's where it was. And he was able to transport these logs right down the center of the flume without touching the sides. Now, the water, as I said, was taken from different levels, and it would rotate one way or the other way. I'll just nip forwards to this one. He had slats set in the sides of this wooden flume to cause the water to rotate clockwise on right-hand bends and anti-clockwise on left-hand bends, always keeping this vertical movement happening. Now, occasionally, along the way, because these various stratified waters mixed and then the stratification was lost, he would put in what he called energy water, and that would come from a stream along close beside the flume with pretty cold water, maybe 5 or 6 degrees centigrade water, and some water was let out, so that the volume of water in the flume was maintained at a constant. And this new energy water was fed in from the side. Well, the thing is that even there with these measures that he put in place, the flume was much more effective in the morning than it was in the afternoon, because a block of wood, the time it was taken, this flume was 2.5 kilometers long, and a block of wood was placed in it, and the time taken to go from start to finish, and that took 29 minutes in the morning and 40 minutes in the afternoon, because in the afternoon the water had become more exposed to the sun and had become tired and didn't want to carry things. That's just a larger design of flume which he built for moving much larger than big logs. And coming back to his voyages out into nature, he came on one of his walks across a very high-lying stream, and he was about to jump over it with his staff when he saw a trout in the stream dash away upwards, and this caused immediately a number of questions to go through his mind. First one was, how did the trout get there? Because he knew that 1 kilometer downstream the stream disappeared into a veil of mist and fell, I don't know, something 60 feet. So how did it get there? And why did it dart upstream? When, I mean, that was against the water, much simpler to go downstream. No, upstream. And how did it stay actually in the water anyway? Because it was sitting in this fast-flowing stream and just doing this with its tail gently. No effort. So actually, he examined it, and the trout sits in the stream where the coldest water is present, where the vortical motion is greatest, and because of the shape of its body, let's say the filaments of water accelerating past the body, which are closest to it, form a turbulence or a reverse vortex in the back of the tail. And this actually pushes the trout forwards. The trout sits in the middle because in this vortex, all the food and little things it likes to eat are right coming straight into its mouth. It only has to sit there with its mouth open. But on thundery days, or days when the weather is worse, then the stream, because of the change in energies, it doesn't flow quite as well, and the trout gets hungry and starts jumping about, which is why you can catch trout better on a thundery day than you can on another day. So, but this process of the actual shape of the body of the trout, which you can see is actually a complex egg shape. This is, or grain shape. That's what the trout's body is made up of. And an egg and these shapes have a great affinity with the movement of water. But in the process of this acceleration upstream, of course, the trout breathes through its gill system. And like us, it extracts the oxygen and other gases come out. And so what happens here is that these sort of yellow bubbles come out of the gills. They're oxygen deficient, and immediately they want to reabsorb oxygen. And the reabsorption of that oxygen increases the volume of the water behind the fish, and the fish is shoved forwards like a bar of soap. So this we'll probably come back to, but I want you to remember some things there. This is a photograph taken from below, showing a trout in the vortex. Another one actually going up into a pipe. The trout seeks out the vortex. That's how the trout actually rose up this stream where Victor Schauberger was, because in Victor Schauberger's view also, there were always two movements of energy in a stream. There was the energy of gravity, which took the water down into the valley. And at the same time, there was another energy which went from the valley right up to the spring. So we had, in a sense, the gravitational effect and the levitational effect. And before I get off fish, because actually I wanted to mention this as well, because of the success of Victor Schauberger's log flumes, the Austrian government decided to ask a retired professor of hydrology, Professor Philipp Forchheimer, to examine his theories. And so Schauberger didn't really want to have him around, but he was very polite and never asked any stupid questions. And so anyway, they came to a stream where Forchheimer and Schauberger were looking at this trout. And Victor waved his stick over it, and the trout went upstream. And Victor said, "Now, Professor, you tell me why this trout flees upstream in fear." And the professor scratched his head. No. And Victor said, "Oh, well, because it didn't have an academic training like you." And they got on actually very well, and they were friends. And then at one moment, because this had been set up, the fish, and Victor knew where the fish was, but he'd also organized some of his foresters to have a cauldron of water of about 100 liters, about 200 meters upstream from where the fish was. And when the fish came back to rest, Schauberger gave the signal, and his foresters poured the hot water into the stream. And as soon as the hot water hit the stream, the fish started to struggle and flap its tail and move backwards downstream. Because, as Victor claimed, the levitational energy moving from the valley to the spring, top of the mountain, had been cut by the heat. Gradually, when all that heat dissipated, then the trout came back to where it was, and peace and tranquility were restored. But these are just some computer programs eggs, showing how fishes can be derived from eggs. I'll pass over it. And an interesting thing here is a little experiment which you can do. This one has a ping pong ball in it, and this is a gas jar. Normally you get it find it in most laboratories, I suppose. And this is a ping pong ball filled with a saline solution, so it has the same specific weight as an egg. And if you stir it, you have to stir really hard if you want to get this ping pong ball to rise. And sometimes it won't. But if you put an egg in there, fresh egg, and you stir the water, you start quite fast to begin with, and then the egg wobbles up. And then you can slow your speed down, and as long as you keep on stirring, the egg will stay there, because the egg responds to the vortex. And it is why also the fish use that shape. In his remote little, on Schauberger Lipper's estate, Victor lived in a little cottage in the, away from the main area, about 5 kilometers, and he wanted to put electricity into the cottage. Electricity was a new thing, in the country in those days. And so he devised a way of making electricity using a generator of his design, which used only 10% of the water normally necessary to provide the same amount of power. And what happened, back again, the water was introduced through this rifled pipe. This, I think, was the shut-off valve. It's not explained in the patent. And the water was then caused to rotate in a vortex, which then impacted on this sort of impeller looking like a shell. While these edges are shown curved, in fact, the whole thing is made up of upward turned grooves like this. And the water impacts on those and spins it. And the last bit here, these last little tails, were to use up the very last momentum of the water before it fell out. And these people in Austria, in Schladming, did set up this arrangement using an egg and a hyperbolic cone, which is the part of the math and geometry developed by Walter Schauberger. And this was going to be attached to the bottom of it. So the water was introduced into this egg, tangentially spiraled, a tremendous vortex was created inside, and then that vortex energy was then directed through this jet at the end of it. When I went there, they hadn't fitted it, but they did try it out, and this cone of water was quite amazing. I took my shirt off, and I stuck my head underneath because I wanted to look up and see what it was like. Well, this water was just like putting your head under a knife. I mean, it was so sharp. It was just amazing, and cold too. So, but no one's actually built one of those, as far as I know. The group somehow fell apart, which is a great shame. Now, this is an experiment which was originally carried out by Rutherford about 1903 or 4, and it's to do with the charge in water and how the charge in water can be built up. This is a device I made, it must be about 15 years ago or something now. Now, water is introduced into this device just normally by a hose, and on each of these arms is a hypodermic needle, the very finest hypodermic needle. And that water then, the jet from that falls through a cylinder of brass, which is coated on the outside with paraffin wax, which is one of the best insulants, and then through into a receiving bucket. Now, in the bottom of this bucket, there is a brass strip, which is attached to copper in this rod, and the copper in the rod is attached to the brass in this cylinder. So in fact, both systems are connected diagonally to each other. Now, when the water falls through, you can hear it for the first 2 or 3 seconds. You can hear it hit the bottom of the bottom bucket, and then afterwards, everything goes quiet. And you can't hear anything. And then something happens, and the charge field is broken, and it releases. Now, what happens is that the water falling through maybe, and that I can't tell you which, it will develop a positive charge which is transferred to this cylinder and a negative one to that one. This positive charge then turns to negative in the bottom, and this negative charge to positive. So a huge charge actually builds up, and this is really a small thunderstorm, at least a thunderstorm on a very small scale, because this falling water produces this particular charge, these opposite charges, and I attached a wire to the two things here, to the two different charge collectors, and I got a spark which jumped 2 centimeters out of it. Now, the rule of thumb is that it's 2,000 volts for every millimeter jumped. So that was looking about 40,000 volts. And I tell you, I really jumped when I touched the wrong thing. So that was an experiment that Victor carried out in Nuremberg to show that how water can develop charges, and this is really quite an interesting little example of how you can do it. Right, is this thing working? I don't know if you can all read that at the back, but I'll read it. The majority believes that everything hard to understand must be very profound. This is incorrect. What is hard to understand is what is immature, unclear, and often false. The highest wisdom passes through the brain directly into the heart. And I'm put that up because now we are going to change our tack, because I have to explain a little bit about energy before I can go on talking about water. There's some things which have to be understood first. At the moment, the way our society developed, we go back in time, the paths of nature, so to speak, or what one might call eco-technology and our technology, ran more or less parallel to each other. Nature's system, evolution, it means development, increasing order, growth, stability, efficiency, and super economy. Because in nature's system, you start with, say, 100% capital, and that is invested into new life forms, new niche objects, new niche creatures, and so that represents a 10% perhaps profit on her original base capital. And then if you invest that 10%, then you get another percent on top. And we should really be involved with living off the interest of interest, because nature's, in order to evolve, you must operate at a greater efficiency than 100%. It's not possible otherwise. So why you look out there, every year a tree's got more leaves, more branches, and so on. So that is obviously a very, very viable system. And in the process of this huge development of nature, every new form, every new life form represented another leg on which to stand. And so there was enormous stability. If you take 100% efficiency, nothing changes. It doesn't get less, it doesn't get more. It's all very boringly the same. But our system of technology is antagonistic to nature. We have a system where we do not achieve 100% efficiency with anything that we use or that we have created. Walter Schauberger talked to Dr. Fritz Kortegast, who was at that time the head of Mercedes-Benz engine department. And Fritz said, our most efficient engines are only 16% efficient. All the rest is waste. So if you take that as your capital, let's say you start out with 100% capital and you invest it into a Mercedes-Benz engine, you get 16% back. And if you invest that, you get 16% back of that less. So we have got a system which is going to take us down to a very, very unstable and very unpleasant place. Here, nature had many legs to stand on. Our technology is reducing everything more and more to uniformity. And so we're coming up to the position now in the world where we're standing on 3 legs. We're standing on the legs of water, oil, and electricity. And if any of those fail, the rest is history. So it's, as I put up there, a rather woeful situation. Now, where are we? Got to look at a few things. Right. I'm going to skip this one because I need to go further. Now, I just want you to, just going to go through these images. I won't say anything about them, just while you take them in slowly. In all those images that you saw, you didn't see a straight line or a circle or a point, which are all the elements of the geometry which is in use to make all our artifacts. A straight line is in Chinese view, was a very highly dangerous thing, and they made sure on the roofs of their buildings to have a little curve because dragons like to move very fast down straight lines, so this slowed up the dragons. Now, we are using a geometrical system which is totally alien to nature. You can't find it anywhere. It doesn't have any resonance with nature, and it doesn't conform to the way natural organisms function or anything that we wish to maintain in a alive condition is not helped by the various shapes and forms into which we store it. The egg, of course, is the form chosen by nature to preserve and provide life. So, the other thing to realize is that energy is primary, that nothing can occur without the energy or the idea of it. What we see as physical form is just the result, the end result of the ideas and the energies it created. And in this little proportion, which was calculated by Dr. Carlos Riber, who got the Nobel Prize for Physics in 1984, the proportion between physical matter and formative energies is roughly 1 to 100 million. Now just think about it for a minute. That means that for most of us, and me included, I'm not including me out, what we touch is what is real. But what we are aware of, actually, is only 100 millionth of reality. So, formative energies, they must be stratified. They go up to God knows where. It's maybe even up is the wrong word. Maybe you need to say they go inside, you know, because something that resides in the center can be aware of all things, can't be on the outside. So these, we have to approach everything from the idea of the energy first. Otherwise, we won't come up with the right answer and how to deal with the problems which face us at the moment, which of course are multiplying. Now, the way it seems to work, according to Victor, is that while there are energies, and we'll say there's 100 million units of energy. These are divided into male and female because it's the interaction between opposites which creates the synthesis, which is the new thing. So here, we could also turn this diagram up the other way around, and it would express how perhaps a tree grows in his view, that here we have the formative energies, the red male, the blue female, and the matter which is drawn into the energy wake. But it's not vibrating at the proper rate, so it gets deposited and is left behind. So, as Victor said, the tree is the result of the energies which have flowed from the Earth into the atmosphere, and this is the substances which has been unable to be drawn up any further. The real energy and life and vitality of the tree is about 400 meters above it. This is what's left behind. So that's a view of a vortex which we did it in Schauberger's establishment in Austria. It's beautiful. All these little nodules, so to speak, or part of the vortex can be interpreted mathematically. They have their right place, and I won't go into that particularly, but that's how the little walls are distributed. Now, so we come back to energy again, and creative formative motion, according to Victor, is open, goal-oriented, structured, concentrated, intensifying, condensing, dynamic, self-organizing, self-divesting of the less valuable, rhythmical, cyclical, sinuous, pulsing, in-rolling, centripetal and out-rolling centrifugal movement. It's called, in simplified version, the cycloid spiral space curve, which has all those movements in it. Now, basically, there are three basic movements. There is orbital motion, rotational motion, and circulational motion. And these are the various ways in which nature engages in movement. And we need to, as I said, to try and copy these and to understand them more. All right. And one of the principal things to understand in this motion is that there are two movements. Nature will pretty well always use the movement from the outside inwards, and our technology always uses the movement from the inside outwards. It's a centrifugal movement. It's an explosion. Nature doesn't ever use explosion except under extreme circumstances like volcanic eruptions and so on. Now, the key words, this is what Victor called axial radial motion. So you move from the axis to the radius, and all the values of destruction, all the values of friction and so on, all increase the further you come away from the center. And the key words for this particular motion are disintegrating, decelerating, dissipating, destructive, divergent, loosening, and friction-inducing. The other movement, and also, I nearly forgot, noise-creating. So a measure of the extent to which an invention of humanity is working against the laws of nature is the amount of noise it makes, because nature doesn't make that sort of noise. Now, here the opposite is the radial axial motion. So it moves from the outside inwards with increasing velocity, increasing centering, increasing speed, less friction, less noise, and a lot more power. And so with radial axial motion, the concentration power is in silence. And if you go out into the forest, there's enormous power, there's enormous creative power out there. There's all the sap moving up to the branches. And isn't it beautifully quiet? Yeah, sorry, well, this is just a full cycle of Saturn, just showing that we do actually live in the planetary vortex. This is the cycle of Saturn. You can find that in probably most textbooks, I guess, but we'll carry on. Now, we come to the thing of thesis and antithesis and the synthesis. Because there are always, in this world of dualities, there is always the opposite. And they are, generally speaking, in a state of balance with each other, of dynamic equilibrium, shall we say. And as long as one exists, the other will exist also. If one ceases to exist, then the other one also ceases to exist. Now, Victor, this is set out a bit more easily to understand. A dialectic unity of thesis times antithesis equals synthesis. And this is the Walter Schauberger's principal equation, 1 over n times n equals 1, where n is any number. So 1 over 2 times 2, a half times 2 is 1, a quarter times 4 is 1, and so on. So the math is really beautifully easy. It's just up to my standard. And these are two columns of opposites, of matter, spirit, egoism, altruism, distance, information density, specialization, generalization, analysis, synthesis, and so on, male, female, negative temperature gradient, positive temperature gradient. And these ones on the left are endowed with male characteristics. So light, gravitation, electricism, expansion, pressure, heat, oxygen, male. And the other one, the blue side, are the one which have female attributes. So spirit, altruism, infinity, order, generalization, darkness, levitation. Darkness in the sense of, in a very sort of, what shall we say, pregnant idea. Magnetism, impansion, and so on. And these opposites are always interplaying in all aspects of the universe in which we live in. But in order for evolution to proceed, then there has to be a slight increase on the right-hand column, because these are the things which actually further and foster evolution. If we were to give these the upper hand, then it would go in the opposite direction. Now, right. The upholder of the cycles which support the whole of life is water. In every drop of water dwells the living God whom we all serve. There also dwells life, the soul of the first substance, water, whose boundaries and banks are the capillaries that guide it and in which it circulates. This is the part of the talk that I've been trying to get to, which is to do with water. I was going to recite a poem of Goethe's in this respect. Yes, I can remember it, I think. How blossomingly I rejoice, all hail to the new. All is born of water and upheld by water too. Transpierced thus am I by beauty and by truth. O great ocean, grant us thine eternal ruth. For wouldst thou not send clouds, nor bounteous streams endow, nor perfect the currents, nor rivers here and there bestow, then where would mountains be? And what of plains and world? For thou alone it is that keeps this precious life unfurled. And this is water. Water is the first substance. Interestingly enough, water is written with a W, and if I take that W and turn it the other way up, it becomes an M. and that says mater, mother. It's the first substance, it's the substance which has mothered all other substances and all life, all organic life forms. There is now, I'll just go through these. So first thing, as we said, water is a living substance. According to Victor, water is the blood of the earth and performs the same function in the earth as blood in animals and sap in plants. Sap, blood, and water are synonymous. Water has as many varieties as there are human beings, animals, and plants. Because water has memory. Water is affected by everything with which it comes in contact. And so all of us, everything that, who we are, it's in touch with our emotions, our thoughts, the water which we have in us. Water has three states of aggregation: solid, liquid, and gaseous. And in terms of this liquid structure, it tends more towards the crystalline. Chemically described as H2O. This is really rather boring stuff, so I'll go on to the next thing. You can find that out in any dictionary, really, or any textbook. Now, this is a diagram which I need to explain one of the very, very core ideas of Victor's and understandings of Victor's about water, and indeed, about energy per se, and that is the temperature gradient. Now, water has its so-called anomaly point at 4 degrees where it's at its most dense. So a temperature gradient, in Victor's view, which is positive, is one where the temperature drops from a higher level down towards 4 degrees Celsius. This is a movement which consolidates and makes the water denser and compacts it. The opposite movement is the negative temperature gradient, which is any movement either upwards or downwards from 4 degrees, where the water gets less dense and, of course, in this direction gets hotter. Because water, the hotter it gets, the lazier it becomes, as I said a little bit earlier in relation to the log flume. And so if you're wanting to organize water flows and so on, then you have to pay serious attention to the temperature gradient, which also is involved in climate at a much larger scale. The other interesting thing on this graph that's all too small to look at is this line here, which is the curve of the specific heat of water. Now, water has the highest specific heat, or one of the highest specific heats of any of the elements, and what it means is that water can absorb more heat without changing its own thermal structure than any other element. So, interestingly enough, the lowest point on this curve is at 37 degrees, which is what is the average human blood temperature. Which means that that's why, with our blood 90% water, we are able to withstand huge changes in differences in climate and heat without actually affecting our own physical temperature inside too detrimentally. Water isn't, you see, just H2O. There are about 33 different substances which make up water, combining different valencies, different ionization states of oxygen and hydrogen and so on. So it's actually quite a complex little bundle. And when it vibrates in 3 different modes all at once. This one is the symmetrical vibration, the first one, where it's actually, it's actually doing the same thing. The next one is the sort of more flapping mode, and this one is asymmetrical, so it's sort of moving like this. And if you put them all together in the bundle, that's what the water molecule looks like. And it takes about 1 million water molecules to make 1 drop of water. This is some diagrams I took from a homeopathic publication. And this shows where, this is the matrix of water. The red circles are all the oxygen atoms, and the blue ones are all the hydrogen atoms. And this is a substance which is not water, which could be some tincture, it could be a bit of apple, or it could be anything which is actually suspended within the water fabric itself. And according to the way that homeopathic preparations are made, the more you shake it, then the more that particular essence is absorbed into the water, and when the very high dilutions come, then that substance isn't there at all, and what is left is a sort of hole where the resonant frequencies of that particular substance are still resounding, they're still there, and they're just as real, remember, as the physical stuff, because, you know, they're one of the 100 millionth energy things which form physical matter. See what I mean? So that is one of the reasons why homeopathy works. There was an experiment carried out by Professor Jacques Benveniste at the University of Southern Paris, and I met him, I don't know, about 5 years ago. Unfortunately, he's died. But he was asked by the Homeopathic Society of France to prove that homeopathy did not work. And so he went into it with that in mind, but found more and more with his research that it did work. And he eventually presented a paper which showed that with dilutions of 1 to the power of 120, which really means 1 to 1 plus 120 zeros, that a reaction still occurred. And that was, you know, was totally inexplicable to science, still is to a large extent. Now, where am I going next? Right. Oh, that's more reading. So here's some idea of what water is used for and how much of it. They're quite alarming. It makes you think twice, for instance, about buying a ton of rayon. I don't know, can you all see these figures at the back there? Because I can read them out, but who at the back can't see them? Oh, well, you're too far away, so that's fine. That's okay. And anyway, I'm married to you, so. Now, this is another one of how much it takes. But look at that. To make one suit is 685,000 liters of water. Oh, well, I better get rid of this, sorry. But I mean, it's just profligate, the use of water, and we don't really give it that appreciation that it needs. Water is living substance. It is the mother substance. It's what supports us all. And I'll read this out again because then I get myself into the picture. Our science views the blood-building and character-influencing organism, water, merely as a chemical compound and provides millions of people with a liquid prepared from this point of view, which is everything but healthy water. Good water, good life. Bad water, bad life. No water, no life. I would like just to point out, in case you're not familiar with it, the word or the prefix which actually comes from earlier English. It is also still current as a prefix in German. It means something which goes back to the first principles or the first origin. So the organism, water, is water which has always been. In fact, as Victor said, water has the aspect of being. Because it's always there, it was there, it's now here, and many things have passed and come and gone, mountains, continents, so on, but water has always been. We are also interested, because we do drink it, on the various qualities of water. Now, these are qualities as described really by Victor Schauberger. Distilled water is the purest water. It's actually poisonous. It can save your life if there's nothing else to drink, but you wouldn't want to drink it otherwise because it's what Victor called juvenile, or not even juvenile, it was baby water. And that grasps at everything in reach because it needs to grow, it needs to become mature. So distilled water will leach out from you all your various stores of chemicals and minerals and so on in order to make itself whole. Meteoric water, which is rainwater, has some atmospheric gases. It has no minerals. It does have a charge from the fall, but it's not a full-bodied water. And juvenile water is the same, except it's coming from the ground up. And these are the ones, juvenile water is water which comes up in springs, which can occur before it has actually matured, and it is full of minerals and trace elements, but has no gases in it. So it's missing something. Surface water, which is in dams and rivers, has, well, 3-star quality because it's now even worse. I'll probably put it back to 2 now because it's also polluted. But generally speaking, it's not, it's got many things in it, but it's just not really high quality. Groundwater has got a greater quantity of minerals and salts. And this, I mean, the groundwater which sits down on the groundwater table, which may be anything from 10 meters to 50 meters or more below. And true spring water, which is high in dissolved carbons and carbonic acid and minerals, is a full-bodied water. It has everything that you need in it. Now, I must just explain something about carbons, because, or am I going to explain that to you in about 2 seconds? No, I'm not, but anyway. Victor viewed, his view of the elements was that hydrogen was a carrier, oxygen was a lower frequency of sunlight and male, and all the other elements were female or mother substances, which he called, in German, carbon. But in English, in my books, I've written an E on the end of it, so it's called carbone, to try and do a sort of shorthand. But that means everything else that is not oxygen and is not hydrogen. So this water, a true spring water, comes out of the ground at the right moment, when it is ripe and fresh and can give life to the surrounding areas and people. Artesian water is deep-lying, and it depends what it's got in it, whether it's actually drinkable or not. The water content of the human body is quite interesting to know about and to be aware of, because everything you put in it is going to go to the furthest extremities, and it's going to affect the way you function. So blood plasma has about 92% water. But can I just say, if everybody can see this, because then I won't read it. Can anyone who can't put their hands up the back? Good, then I won't read it. I'll let you read it. Give me a break from talking for a moment too. Right. So it's really quite fascinating, you know. And here the brain cells, I mean, they're 85% water. And what happens when you start shoving, you know, Diet Coke in there and all those other things? And your thinking, your ethics, your mind, your behavior, that's all controlled from the brains. It's irresponsible to drink that sort of stuff. Now, we are concerned, and Duncan brought it up, you know, we've got chlorination, and now we're going to have fluoridation. And just to give you an idea of what, because chlorine is normally administered at about 10 parts per million, In some countries where the climate is rather hot, they put a bit more in. But 1 part per million is a centimetre by a centimetre by a centimetre in a metre cube box. That is 1 part per million. So 10 parts per million is a little row of cubic centimetres, and that is what is put into the water supply. But I did talk to you earlier about the homeopathic dosage and the efficacies of it. So when we drink that, what we are doing is actually sterilizing ourselves, because the water, the chlorine is put into the water to sterilize the water, and we drink it and we sterilize our own bodies with that. We interfere with the proper functioning of the cells and the proper movement of liquids in the body. One of the things that chlorine does is it ousts the oxygen from the water molecule. So, and what you have instead is a hydrogen chlorine combination, and oxygen is released. And that oxygen, of course, has nothing to hang on to, so it becomes a free radical, and it does all sorts of damage in the body, makes you look older, and so on. It's something to be avoided. Originally, and then now they're going to have fluoride, which originally started out as a byproduct of the aluminium industry in terms of sodium fluoride. It was first used as a rat poison, worked very well. And it was probably done, well, let's be kind, because calcium fluoride was perceived to have some benefits for the health of teeth and the body and so on. And calcium chloride does occur naturally, and certainly people who live in places where there's more of that in the water, they've got strong bones. But sodium fluoride is really bad news, and it makes the bones brittle and so on. So unfortunately, governments have become dictatorships these days, and you can't really get them to change their minds. Right, next. Right. According to Victor's processes, these are the ingredients you would need for putting together about 10 litres of water. These are the more necessary additives into a base water, shall we say, in order to create a good quality drinking water artificially. And then the question arises, once you've got it, what you put it in. And here we come back to natural shapes. The shapes that basically nature has selected for the preservation or propagation of life, which are, in terms of the amphora, a rather grain-shaped form, or in terms of eggs. And these shapes have resonances which seem to preserve whatever the contents are. There were some amphora like this, which were sealed with beeswax, and they were filled with corn and buried in the Middle East. I can't remember the exact place, about 2,000 years ago. And they dug them up and opened them up and planted the corn, and it grew. So these are the shapes we should really be thinking about holding our vital fluids in, because here in the egg there are no corners. There are no surfaces in there where there's any stagnation. This is an egg which is derived from Walter Schauberger's mathematics. And there's one out there which belongs to Duncan, which you can have a look at. But the way it functions is that in the process of evaporation, because it's an evaporative body, it means it's a breathing body, it's not sealed from the outside, It can also take in the energies, the external energies, and transmit them, its own energies. And through the processes of evaporation, the surface gets cooled, and the water immediately next to, adjacent to the outer surface, gets cooled, and being specifically heavier sinks to the bottom and displaces the warmer water there, which goes up the center. And so you have this constant circulation of water, not quite as violently as that seems to show, mind you, it's actually much slower, but you have this constant movement of the water inside, so there's no stagnation. The water is always moving, and so in the sense, and what is movement? Movement is energy, or energizing. So this is a picture, I got them in the wrong order, but this is just showing hydrogen as the carrier of oxygen and carbon. Come on. And this is an aspect of drinking water which is important to understand also, and it's the relation between carbonic acid, water, and carbon dioxide. High-grade spring water contains carbonic acid as well. So high-grade spring water is made up of, has a content of H2CO3 in it, which is what the element in the water which gives it body and fullness and, you know, taste and the feeling of well-being when you're drinking it. And with cooling, H2O, which is ordinary water, and carbon dioxide combine to make carbonic acid, which is also known, carbon dioxide is also known as carbonic acid gas. But with heating the presence of light, then the reverse process takes place, and carbonic acid transfers back into water and carbon dioxide. And when you take some really good water and you put it in a glass and you put it out in the sun, after a while you'll see little bubbles form on the inside of the glass. And that is all the transfer of carbonic acid into water and carbon dioxide. And that represents an energy loss in the water, because those bubbles then disappear up into the atmosphere. If you shake them and they're all gone and they're lost. So the CO2 has been lost from the water has been de-energized, and when you drink that water, it tastes really, really flat and, you know, tired, which it is. And and this is just an example. These are Chladni plates. These were taken from a book by Hans Jenny. Just to show you what the effect of heat is. It's quite graphic in the sense that these are black metal plate, maybe 2 millimeters thick, which is vibrated at a certain frequency, has sand placed on it, and the sand reproduces the image that that frequency does to the plate, the way that the plate bends and vibrates. But if, when you have that, and then you touch the corner of the plate with a torch or a lighter, a match to it, then that structure suddenly ceases. So heat is a great destroyer. Heat is a great destroyer of the even flow of water, as we saw, as I told you about in the trout experiment. And water needs to be protected from light and heat as far as is possible. This was a bit of research which Victor did, which shows the difference between the structure of water if it's moved centrifugally, which means from the inside out, or centripetally from the outside in. And all our means, all our pumping systems, our power systems, all use centrifugal technology. So the water is destroyed as it's passed down the pipe to us already, or it's destroyed in the river. When it passes through the Pelton wheels in a hydroelectric power station, the water is disintegrated. The oxygen is thrown out of it. It gets on the back of the turbine blades, starts eating them away, and the water comes out. And if there were fish at the outfall of the dam, and they die very quickly because the water wants to grab the oxygen out of the fish or anything else. And so there are quite a few cases known where when a dam has been established and set in motion, that the fish have died in the stream. The temperature gradient and the anomaly point of water we're going to talk about now in a bit more detail. Right, so as we move up the atmosphere, we can see that there are certain points where this 4 degrees occurs. So it doesn't constantly get colder as we move vertically. There's always a stratification of things. And so between these points, for instance, here it'll get colder, then it'll get warmer between these ones. So at this level it's warmer, and then it gets cold again. And up here, then the temperature rises. And this is one of the funny little things, you know, they don't teach you at school, or they might teach you if you're a graduate at university, is that temperature is not only thermal, but it's also a measure of energy, or the energetic motion. So, yeah, well, when you get up higher, it's got to be cold up there because there can't be anything much to keep it warm. And so it sort of backs up one of Victor's sayings, which, is quite stimulating. That the sun is a cold, dark body. The closer we get to the sun, the darker will be its face. Everything in nature is indirect. So the indirect thing is that from the darkness of the sun, we get light. And if you think about it and just say, it's all beyond all reason. The sun radiates extremely high frequency, high energy at the earth, none of which is thermal. And the light from the sun, as it were, the energy impinges on the Earth's atmosphere and it slows down and demodulates to frequencies which are then falling into the light spectrum, and we can see it. However, that's what you said. I'm sorry, that was quite a bombshell. You weren't expecting to hear that one. Right. Now, coming back, we're going to get on with water because this is where we live and we've got to deal with things. Now, what Victor calls, there are two hydrological cycles. There's the full cycle and there's a half cycle. Now, the full cycle is when the temperature of the ground is cooler than the temperature of the rain. That means there's a positive temperature gradient in the movement of temperature from the earth or from the water in the rain into the ground. And that means that the ground will absorb the rain. That water is absorbed, it sinks down, it recharges the aquifers, it's taken up by the tree roots, some of it flows out to the sea, and then it rises back into the atmosphere again. And on this diagram, on the full hydrological cycle, you see that the spirals of the rising evaporative water, is going in two different directions. It's not to make one better than the other, it's just to say that they're different. Because the water rising from the sea is arising from a huge mass of water, which, while not dead, doesn't quite have the same intimacy with the atmosphere as trees do with all their branches and leaves and so on. And so that the energies arising above the tree with the evaporation, those are entirely different energies to the sea's energies. Now, I talked to a glider pilot in Austria, and he actually took me up in his glider. And I said to him, yeah, well, why don't we go over the town there? There's a lot of heat coming up, and, you know, you'll get up faster. And he said, oh, no. You can only rise upwards over the forest. You can't do it over towns. It doesn't work. The heat is wrong. It's not the right sort of heat. Anyway, so these little particles of moisture, they rise up higher and higher in the atmosphere. They eventually consolidate, cool, consolidate, and fall again as rain. But they have been up where they get more information from the sun. So they bring that information back with them, added to which there is the charge generated in the fall distance to Earth, which is like that little experiment I showed you with the jets. So the water actually gets charged, and when the rainwater hits the plant, there's a huge boost of energy which the plant absorbs, which doesn't happen with irrigation water because the fall distance isn't there. So that is a self-reinforcing process and builds up the vitality of the ground and the whole of nature, and also indeed the stability of the Earth's atmosphere, because with this system, the full hydrological cycle, the atmospheric water distribution is pretty even. So it's very stable. But we have engineered the half hydrological cycle. And practically the whole of the world is now suffering from this half hydrological cycle, where because we have cleared so much, because we have used bad farming practices, we have changed otherwise green areas into green water absorbing areas into hot ones. And so here what happens is that we have a negative temperature gradient between the atmosphere and the ground. And that means that when cool rain falls on a warm ground, it won't penetrate it. It's like falling on a hot plate. It just goes sideways. So we are very responsible for this tremendous disturbance in the atmosphere. We are, as Victor said, he said this in a book called Our Senseless Toil, written in 1930, if we continue with our current practices in water resource management, forestry, agriculture, and energy generation, the Earth will heat up, and then it will go cold. And this is, maybe this doesn't have to happen if everybody felt, if they got out there and really understood to work with nature's laws and not against them. So we re-green and the countryside. We plant trees. We try and re-establish the proper spiral movement out of the earth. Here it's all red. It's destructive. And it's a form of energy which is destructive, and then that destruction gets reinforced by the other energy and information it receives from the sun, and so it becomes even more destructive, and it falls as flood rains and cyclones and God knows what else. Right. Now, I think I might just have to be nearly at the end. I'll just see what else is coming. Oh, yes. Oh, well. All right. Oh, no, we'll go back to that one. I haven't time. This is terrible.
You get the spring story.
Yeah, you get the spring story, okay. The spring story is there are two different kinds of spring. There is a seepage spring and a true spring. Now, this is a seepage spring, which under the correct conditions of a positive temperature gradient, instant rain will percolate into the ground, come against an impervious layer, and then run along the gradient according to gravity, and will emerge probably at a temperature of somewhere around, well, anywhere around 8 degrees, 9 degrees. And it will taste good, but it's not true spring water. True spring water is different in that we have the same penetration of rainwater under a positive gradient, which seeps all the way down. And but there is a counter pressure from below, which is the expansion of geothermal heat, which pushes the lower, very low strata of water upwards. So gradually, as the water comes down, it cools, and it gets compressed by this movement from the bottom upwards. And so in the middle of the groundwater table, there is the 4-degree center stratum. And this is at 4 degrees. What this stratum does not have, though, is its full content of dissolved oxygen, which has been absorbed by the tree roots and so on the way down. So this water, this center stratum, is what it had the character that Victor described as nymphomaniac, because it had removed from it in the process of all this infiltration its male aspect, the oxygen. And it wanted desperately to reunite with its male aspect in order to become whole again. And it would find any avenue fissure to rise up to where oxygen was present. And there are many mountain peaks where springs occur, but there's not a catchment area sufficient to supply the volume of flow which is coming from the spring. Now, on some occasions, they had in Austria, high up, they had what they called poison springs, and they fenced them off from cattle, because the cattle, if they drank that water, would die. They would get what was known as galloping consumption. And the reason was that the water in the spring coming out had not yet absorbed oxygen, so it was basically carbon dioxide brew, and it would choke anything that breathed it or drank it, because it was going to get the oxygen out then. Now, okay, I derailed myself there just slightly. But anyway, after flowing about 10 meters or so, Victor observed the volume of water coming out of a true spring when it came out, and about 10 meters further down he measured the quantity, and it had grown. And it had grown because, and it expanded because of its absorption of oxygen. Okay, just one more slide, and then I'm going to stop. And using this principle, we should be able to generate energy from the deep sea at virtually no cost, because we actually have the similar situation that happens on land, where we have water, we have organisms in the sea which gradually deplete the water of oxygen as you go further down. We have a cooling as you go further down. We have also an upward pressure from below. So somewhere, at some depth, there is going to be a stratum of 4 degrees centigrade, which is oxygen efficient. And if we were able to introduce a pipe down there, which has an intake which caused the water to move in a vortex as it moved in, and we bring it up to a certain point, and then this is a detail of this part, and then we infuse atmospheric oxygen into it, which causes this oxygen deficient water to expand, then we have power to drive a centripetal generator. And all that comes out at the end of it is oxygenated seawater, which was there anyway. So we didn't hurt anything. Right. So all these things are, they're all possibilities. Victor Schauberger has shown that there are a huge number of things we can actually do if we want to try and change things. But everything is interconnected, and I wanted just to finish with this another short poem by Goethe. All things into one are woven, each in each doth act and dwell, as cosmic forces rising, falling, charging up this golden bell, with heaven-scented undulations, piercing earth from power sublime, harmonious all and all resounding, fill their universe and time. Amidst life's tides in raging motion, I ebb and flood, waft to and fro, birth and grave, eternal ocean, ever moving transient flow. Such changing, vibrant animation, the very stuff of life is mine. Thus at the loom of time I sit, and weave this living cloth divine. Thank you.
Thanks, Callum. That was your usual high standard. Thank you very much. If you want to chat to Callum, he's at a stand where the nice egg-shaped amphora is out there, so feel free to ask him questions. Quite a lot of the speakers have a stall or an exhibit out there, so feel free to go up and start asking questions of any of the speakers that you have information about. Right now we have a half-hour break, so please go out there. You'll find that the water in those cisterns out there is spring water. It's the good stuff. So we'll see you back in half an hour sharp. Thank you very much.